My dear students, other viewers and listeners, I, Professor Manohar Lal, Director, School of Computer and Information Sciences, welcome you to this couple of lectures on the Artificial Intelligence Programming Language LISP. Friends, we have already discussed that there are a number of characteristics of the problems which may not be applicable to the algorithmic solutions. Therefore, we have to find out alternatives to find solution of the problems which are not amenable to algorithmic solutions. And artificial intelligence is a baggage or is a bundle of techniques which are used to solve such difficult problems. Mainly we found in our previous lectures that artificial intelligence deals with problems in which mostly we are handling non-numeric aspects of, and in which instead of the sequential solutions, these may require other type of solutions. Now, in order to solve problems with the help of AI techniques, the languages used also have to be different, because most of the languages which are used for algorithmic solutions are actually meant for numeric solutions. And therefore, in view of the fact that the AI or artificial intelligence techniques are used for non-numeric based problems, therefore the language which is used for solving these problems has to be also different. In artificial intelligence, there are mainly two languages which are used for expressing solutions of the problems. One is LISP, which is dominantly used in artificial intelligence circles, and the other is Prolog. Today we will be discussing the language LISP. Later on sometimes we will be discussing the language Prolog also. So friends, now let us come to what are the major characteristics of the language LISP. So first of all, in this context, I would like to discuss various styles of programming: the imperative, the functional, declarative and object-oriented. Everybody must be familiar with the imperative style of solving problems and the object-oriented style of solving problems. Imperative style of programming is mainly for the purpose of giving commands. If the income is more than this, then do this. If otherwise you do like this, etc. So in these cases, most of the program, that is the instructions which are to be executed by the computer system, are in the form of do this, then do this, etc. This is called imperative style of programming. The other very well-known style of programming is object-oriented programming, in which the data and the operations on the data are defined together in the form of objects, etc. However, there are other styles of programming also, and one of the styles of programming is functional style of programming. In functional style of programming, what we do is actually the problem is expressed in terms of a functions, where each function can call other function or its own self, and this is basically the base of functional style of programming language. LISP is also one of the functional style of programming language. Next, I tell you what this name LISP means and what is its origin. Friends, LISP actually stands for list processing. That is, from the word list, T is cut, the three letters are remaining LIS, and P stands for programming. So list processing rather is the complete word, the abbreviation of which is LISP. Now I'll briefly talk of its origins. Most of the programming languages have been designed by a group of leading programming designers and all that. However, Lisp is a language which is designed by a single person, and that single person happens to be one of the colossus, one of the biggest names in the circle of artificial intelligence, namely McCarthy. McCarthy actually designed and developed this language between 1956 to 1960. He is the father of the language Lisp. In addition to the contribution of McCarthy in designing the language Lisp, he has made lot of contribution to the field of artificial intelligence. It can be said that most of the artificial intelligence is either due to McCarthy or his students and students and so on and so forth. So he is the great grandfather of artificial intelligence. So McCarthy designed this language between 1956 to 1958. Next we'll talk briefly what are the characteristic features of the language Lisp. Friends, I already told that Lisp, being a functional programming style language, expresses the solutions of the problems through definition of functions. This is one of the main or characteristics of the language Lisp. In addition to that, 2 or 3 very important features of the language Lisp make it very popular for applications to artificial intelligence based solutions of the problems. One is that in this language, the data as well as the program are expressed in the same format, that is in the form of list, which we will discuss sometime later. That is, there is no differentiation between the data and the program expressions in the language. What is the advantage of this characteristic feature of the language Lisp? The characteristic feature of Lisp is that sometimes even the programs may become data. For example, in a program there are some spelling mistakes or something like that. Now if a spell checker is used, in that case the spell checker is the program and the data becomes the program expressed in that particular language. So what I mean to say, many times it may happen a program may be working as a data in some other way, and if we can write the data as well as program in the same format, we will not have to change the format when treating a program as a data. It is a big advantage. The second characteristic feature of the language Lisp is that it has a few data structures. Namely, there are only 3 data structures in Lisp, and out of that there is only one which is dominantly used, and that is the list, L-I-S-T. The name of the language is L-I-S-P, but the most important data structures in the language Lisp is list, L-I-S-T. Apart from that, there are 2 other data structures, namely atom and string. But as I mentioned, in most of the cases, while writing programs as solutions of problems, we will be using list as a data structure. The third characteristic feature of Lisp is that the operators are prefixed to the operands. What I mean to say, if you have to find out the sum of 3 plus 4 plus 3, 4 and 5, then in that case first of all we will write plus, then we will write 3, 4, 5. That is, the operator plus has to be given in the beginning before the operands like 3, 4, 5. So these are some of the characteristic features of the language Lisp. Next we will go discuss what are the major data types and data structures in any in language Lisp. We know for every programming language, data types and data structures make a very important part of the whole language structure. Then we'll discuss some inbuilt functions of LISP and some special forms of LISP, namely different, con, do, let, etc. And if time permits, we'll discuss the concept of recursion, in how recursion is expressed in LISP, and finally we'll have an example of problem solving through the language LISP. So these are some of the topics which we will be discussing in today's lectures. So let us start with the first one. As I mentioned, in any programming language, the built-in data types and data structures form very important component of the whole language, because depending upon the data type and data structures, the facility of solving particular problems depends. If the data types and data structures are not properly defined, expression of the data types and data structures may become very complicated. However, if these are well thought out and defined after taking into consideration all the design issues, then it facilitates the expression of the data and hence the solution of the problem also. So friends, before we go into the details of what are the data types and data structures in LISP, we have to know what is basic definition, that is an S expression. An S expression is a sort of valid object. Valid object is sometimes you write a name, dog, D-O-G, it makes some sense. However, if you write O-G-D, it may not make a sense. So those words, and when the words are written in a sequence, for example, man eats food, food eats man. Now the second one is not correct because we don't get any sense out of it. So what expressions carry sense should be taken as valid objects, and rest of the expressions which don't carry sense should be taken as invalid. So in a language, whatever is expected to carry sense is called an object of that particular language. In the language LISP, any valid object is called S expression also. So friends, S expression means anything expressed in the language LISP which can carry some meaning. So with this definition of valid object or S expression, now we go into the discussion of the data types. So next slide is very important for our purpose. As I mentioned, at the top is S expression. S expression means any valid expression. Any valid expression is an expression which can carry some meaning in the language LISP. So there are three main data types, as I mentioned in the beginning itself. One is called atom, the second is list, and the third is string. And friends, as I mentioned in the beginning itself, most of the time when we are writing programs in the language LISP, we are dealing with the second data structure, which is LIST. Very frequently only list will be there. Once in a while we'll come across atoms and strings also. Now atom has a number of other varieties also. A symbol, you know, car, dog, man, Mohan, Krishna, all these are symbols. So any symbol, that is any sequence of characters which does not begin with a number, is called a symbol in the language LISP. The second type of atoms are numbers. Numbers are actually sequences of digits 0, 1 to 9, possibly containing decimal and sometimes E also, and character is some single letter, A or B or C or something like that. So The data type atom has three categories at the top, namely symbol, the number, and character. Within the category of numbers, we further differentiate between the integers, between the floating points, and the complex numbers. All of us know how the representations of three subtypes of number are defined and carry meaning of. I don't go into much details of this subtype of the type atom, because as I mentioned in the beginning itself, that the programming language LISP is mainly defined for the purpose of non-numerical solutions of the problems. So of course numbers may occur, even the numerical operations like plus, minus, multiplication, division also may be once in a while applied to numbers, but most of the time we will not be dealing with numbers. So I leave the subtype number here itself. Then we come to the next most important data type, list. We'll see within a while how list is expressed and how it is evaluated. And finally, the data type string at the top, that is any expression which is enclosed between double quotes on both sides is called a string. So once again, to be clear, I repeat that the S expression is any valid expression. An expression is a sequence of characters, and if this sequence of characters may be expected to be meaningful, then it is called valid object or S expression. And the S expressions or valid objects is divided into three subcategories, namely atom, list, and string. And I mentioned, I repeat for the sake of emphasis, that the most important subcategory of valid expressions is list. So with this we go to the next. That is, now I come back to the detailed discussion of the three types of S expressions or valid expressions which I mentioned. The first subcategory of valid atoms or data type is atom. Now what is an atom? So please look at the slide. Atom is further divided into numbers and all that. Here I am discussing the number subcategory of atoms. A number is a sequence of digits possibly involving a dot and a letter E appropriately, so that the value is either an integer or a real number. The following are examples of numbers. 87, everybody knows, is a number. 35.98, 11.5 e minus 3, which represents 11.5 raised to power minus 3, and minus 14 point, you note the point, E3. Here minus 14 point represents actually minus 14, or it also represents minus 14.0, and raised to power 3 is indicated by E3. So all four rather, represent numbers. Some of these may be integer numbers, some may be real numbers, etc. So this is one of the subtype of atoms, that is numbers, and we have seen the examples of number representation in the language LISP. Next we go to the second category of atoms. The second category of atoms is symbols. Now symbol is actually any sequence of characters which does not involve pair of parentheses and does not involve double quotes, then it is a symbol. I should emphasize at this stage that the most important characters in the language LISP are pair of parentheses, which we will see during our discussion of the subject, but in order to emphasize, I repeatedly will be announcing that the pair of parentheses is the most important pair of characters in the language LISP, and therefore don't use those in arbitrary manner as we do in other languages. Here an extra pair of parentheses may lead to a totally different meaning in the language LISP, which is not true in the other languages. In the other languages like C, etc., if you use extra pair of parentheses, it may not change the meaning. However, if an extra pair of parentheses in the language LISP may completely change the meaning, intended meaning. So, now let us come back to the second subcategory of the atom data type. Please look at the symbol. A symbol is a string of characters not representing a number and does not include parentheses and quotes. Each of the following is a symbol. 3 plus 11 star name star block hash 8. Some of us may be surprised that 3 plus 11 is said as a symbol and not a number. But please go back to your definition whenever we have some doubt. Our definition says that any sequence of characters, the 4 characters involved in 3 plus 11 are 3 followed by plus followed by 1 followed by 1. Now, in this particular sequence of characters, there is a symbol, namely the cross, which represents plus, is not a digit. A number must not involve a cross. We have already said a number is a sequence of digits, possibly including dot or possibly including E. Apart from dot and the symbol E, a number cannot include any other character except the number digits 0, 1, 2 up to 9. Here in this particular case we see 3 plus. Here this plus is not used as an operator, rather it is a symbol in isolation and then followed by 1 followed by 1, and because these 4 characters 3 followed by plus followed by 1 followed by 1 include a symbol which is neither a dot nor an E nor any of the 10 digits, namely 0, 1, 2 up to 9. Therefore, this expression 3 plus 11 is not a number but a symbol. You know, the case of other two symbols which are given in here, I don't think there is any confusion, but the first one definitely may lead to a confusion why 3 plus 11 is not categorized as a number but a symbol. I hope I have given the clarification for that. However, there are two symbols which don't follow the rule given above. One is just pair of parentheses. As I mentioned earlier, when a pair of parentheses occurs in an expression, that expression is neither a number nor a symbol, but it is possibly a list, possibly. But here is made an exception. The exception is that whenever a pair of parentheses stands alone, they are not containing any other symbols between them or outside them. In that case, that pair of parentheses may stand for a symbol also. Similarly, there is another exception for symbols, NIL, nil. Nil actually may represent a list also, and of course by definition nil is a symbol because NIL is a sequence of characters which does not involve all the digits, etc. Therefore it is a symbol as well as a list also, and sometimes it may represent empty list and sometimes it may represent even the truth value false. So we have to be careful that there are two special symbols here introduced or talked about. One is pair of parentheses which represent the nil list, and there is another one, NIL, which may represent either a nil list or the truth value false. Friends, as I have already explained, however, if you really intend to find out the sum of the two numbers 3 and 11, now how we should express in the language Lisp? As I mentioned just now, 3 followed by plus followed by 11 is not a number. It does not tell us that the plus operation is to be applied to the two numbers 3 and 11. It is just a symbol. Then how to express that the two numbers 3 and 11 should be added and the result should be delivered to us? Because such operations will occur very frequently while solving problems. Now for that, as I mentioned in the beginning itself, that for such type of intentions, first of all, the very operation itself, the operator has to be mentioned followed by the operand. In this particular case, you can see at the bottom, the pair of parentheses includes plus as the first symbol, followed by 3, followed by 11. I mentioned in the beginning itself that the operators have to be prefixed to the operands. What I meant actually is that first of all, the operator here, the cross or plus, is to be given, followed by the two operands 3 and 11. Here, in this particular case, if such an expression is there, then the Lisp environment will interpret it as find out the sum of two numbers 3 and 11, and the result will be 14. But if you go one line above, 3 followed by plus followed by 11, then the Lisp environment will not return 14, rather it will return 3 followed by plus followed by 11. I hope you understand the subtle difference between 3 plus 11 and the last expression in green, that is a pair of parentheses containing plus followed by 3 followed by 11. Next we come to the next least important data structure. First of all, I mentioned the atom is a data type, and I discussed its subcategories, namely number, symbol, etc. Next, I mentioned that another data type is string, and how the data type string is distinguished from the other data types, namely atom and list. The string data type is discriminated from other data types by any expression when it is enclosed between pair of double quotes. Then this represents a string. As for example, we have double quote followed by ABC, followed by blank, followed by 2, followed by again a blank, followed by at the rate, followed by blank, and then followed by string, followed by double quotes. Now in this particular case, because we have double quotes at the two extremities, therefore whatever is written inside is treated as a string by the Lisp environment. However, if one of the double quotes is missing, either the beginning one or the end ones, then it is not treated by the Lisp environment as a string. As you can see in the last but one line, we have a double quote, square of 2 is 4, which is not followed by double quotes, and therefore this is not treated by the Lisp environment as a string. Next we come to the most important data type of Lisp language, namely list. A list is any sequence of S expressions enclosed between parentheses, where an S expression may be an atom, a string, or another list. Thus the definition of list is recursive. Friends, I like to say something about recursive definition. A recursive definition is one which defines the value in terms of its own partial definition. What do I mean by this? By this we mean, for example, I illustrate it through an example. For example, the factorial of n is defined as n into the factorial of n minus 1. What does this mean? That the n factorial value is not completely given in one go. Rather, it is defined in terms of the partial definition of factorial. For example, if you want to find out 4 factorial according to this definition, what is this definition says? That the 4 factorial is equal to 4 multiplied by 3 factorial. This means that in order to get the value of 4 factorial, first of all you must compute 3 factorial. Again, in order to find out the value of 3 factorial, first of all it is defined as 3 multiplied by factorial of 2. Again, you don't get the complete answer for 3 factorial. What to talk of the complete answer for the value of 4 factorial? Again, you will have to find out the factorial of 2. The factorial of 2 is equal to 2 multiplied by factorial of 1. However, finally we know that the factorial of 1 is equal to 1 given as a part of the definition. And now we'll go backwards. We'll substitute the value of 1 factorial, which is equal to 1 in the definition of 2 factorial. We'll be getting 2 into 1 equal to 2. Now you go back. 3 factorial is defined as 3 multiplied by factorial of 2, which is 2. So 3 factorial will become 6. And ultimately 4 factorial is equal to 4 multiplied by factorial of 3. So in this definition of factorial, you have seen that the value of any integer's factorial is defined partially in terms of the factorial of some easier number. Such a definition is called a recursive definition. Similar approach has been used in defining the list data type of the language LISP. We will have some examples on the next one. For example, the first characteristic or requirement for a list is that the expression must be bound by a pair of parentheses. Now you see, in example 1, the outermost 2 symbols are pair of parentheses. So the first condition is satisfied. Now what is the second condition? For this expression to be a list is that inside either a symbol or another list may occur. Now the cross, which is a symbol, occurs. Therefore, according to the definition of list, any expression bounded by pair of parentheses which may contain a symbol or another list, the first part satisfies the condition because it is a symbol plus. Now you come to the second. The second part of this is again a pair of parentheses containing star x3. But because it contains pair of parentheses, so it is possibly a list. If we remove the internal pair of parentheses, the inside we have a star which is a symbol, inside we have x which is also a symbol, inside we have got 3 which is a number. So the 3 contents of the sub list sort of thing are either symbols or numbers. So second is also a list by definition, third is also similarly is a list by definition, and the largest expression in this particular case is a list which contains 3 elements at the top, namely plus another list containing star x3 and another list containing minus y1. So it is a recursive definition. Why it is recursive? Because in the definition of this list, bigger list, first of all we are having two sublists, namely pair of parentheses enclosing star x3 and another list pair of parentheses enclosing minus y and 1. So lists are parts of the bigger list, and therefore it is similar to finding out n factorial in terms of factorial of n minus 1. Similarly, in example 2, you can see this is also an example of list, because for an expression to be a list, the very first requirement is that it must be bounded by a pair of parentheses. On the left parenthesis, and on the right parenthesis. So in this particular case, because pair of parentheses are enclosing the whole of whatever is there, therefore the first condition for this expression to be a list is satisfied. Now we go inside. Sum SQ is a symbol. As I mentioned in the beginning itself, any sequence of characters which is not an integer or a number, then it is a symbol if it doesn't contain a pair of parentheses or pair of double quotes. Because sum SQ does not contain either a pair of parentheses or pair of double quotes. Therefore it is a symbol. Then the next one is, according to our definition, is a list, sublist. And the third is also a sublist. Therefore the second example also satisfies the condition of being a list. Similarly, we can justify that third is also an appropriate list. Now, what is not a list? Whenever we are explaining a concept, in addition to the valid examples, we should give some examples which don't satisfy the condition. And here in this particular case, I am giving two examples which don't express or represent a list. The first one is, you can see 3, comma, etc., etc. Now, one of the conditions for a valid list is that at no stage the number of right parentheses should exceed the number of left parentheses. And in the first example, 3 followed by comma followed by 2 right parentheses, we can see the number of right parentheses in this stage is more than the number of left parentheses, and therefore it is not a list. Similarly, on the similar grounds, we can reject the last line expression also as not a valid list. So this is examples of the list. Friends, I mentioned that list is the most important data structure in language Lisp, and we discussed its expression in the language Lisp. That is, a list is expressed, first of all, it is a sequence of characters in which the leftmost character must be left parenthesis and the rightmost character must be a right parenthesis. Then inside, either symbols or smaller lists may occur. Now the next question is that whenever a program expressed in the form of valid expressions or S expressions is given to the Lisp environment to execute, how it is evaluated? This evaluation is a bit tricky issue in the sense that when you say add 40 to 39, in some languages it may be written as 40 plus 39, in another language it may be written as pair of parentheses binding plus 40 and 39. How the computer system act on these and find out the final answer as 79. 40 plus 39, but if it is written 40 cross 39, as I mentioned in the Lisp, it will remain 40 cross 39, it will not become 79. However, in some other environment like C, it may become 79. How it happens in one environment and not other? Actually, whenever we write a program, so first of all, it is converted into machine language, and then the execution part starts. And the execution part only acts when the expressions are given in a form which is acceptable to the environment of the language under consideration. So, ultimately what happens, that whenever a program written in a high language is translated by inbuilt mechanism into a program into machine language, ultimately the environment tests for validity of various expressions, and if the expressions, sub-expressions are valid, then it executes those. So in the case of LISP also, how the LISP environment works, it is something like this, as is explained, that first of all, the LISP environment contains a read, eval, print loop function which continuously works when the LISP environment is there. That is, whatever you type on the machine, it is first of all read. Then its value is found, and finally the value is printed. And how we know that the LISP environment is ready to receive from us the inputs? The symbol which is horizontal arrow pointing towards the right is prompted by the LISP system in order to show its readiness to accept inputs from the user. I repeat it again because it is very important that whenever we write a program in a high level language, first of all, it is converted to machine language, and when it is converted to the machine language, it is executed by the inbuilt processes given in the environment. So in the how we know that the environment of that particular language is ready to accept? In the case of LISP, it is indicated by the LISP environment by prompting an arrow, horizontal arrow pointing to the right. That is, you will not type it. It will automatically come, and it will indicate that now whatever you will type will be first of all read, then its value will be found, and finally the value so found will be printed also. In order to explain it further, I show it on the slide. The slide shows that if you have a symbol T, then its value is always interpreted as true. And if the atom or the symbol under consideration is NIL, then it will be interpreted as either logical false or it will be interpreted as empty list, depending upon the situation. We take further example now. For example, the horizontal arrow on the left is prompted by the system, and after that you printed the character 8 followed by 9, which in generally is interpreted as 89. Then the LISP environment first of all reads the two characters 8 followed by 9. Then it finds by the inbuilt mechanisms in the system that it is the number 89, and then it types the number 89. The second 89 is typed by the system, whereas this 89 to the right of the arrow is typed by the user, that is you. These are two different things. So a number when typed to the right of the arrow, then the number's value is same as we treat as human beings. Next. Now there are quoted expressions. Again the arrow is prompted on the left hand side, and we will type an expression on the right hand side, if it is preceded by a quote, then its value is unquoted one.